is actually what do you call it, a demo I put together to sort of gather tweets, do some sentiment analysis against that, and specifically with regards to the elections that are happening in the US. Okay. And yeah, and the whole idea was to sort of find out what different countries, how different countries felt towards the elections, what's happening over there. Okay, and it's quite interesting. I'll show you the results in a bit. So this is NiFi. This is the actual tool. This is not the. This is the actual Dataflow tool, and what it will allow you to do. I'm just going to sit here and talk while I do. So each one of these boxes is basically a processor, and each one of these boxes will allow you to do some kind of function. So the first one over here is basically it grabs data from Twitter host. Second one pulls key attributes from that data. So it pulls things like we're pulling, let's say, I think the user ID, the actual message, time zone, and a few other things. I think we can actually look at it here. View configuration, properties, and you can see all the things. So the user screen name, the text.
So when you say boxes, these are actually units of work, not physically distinct nodes, right?
Oh no, yeah, these are just units of work. So this entire thing is one data flow, and it's all running on one node. Okay. So each one of these is actually what we call a processor. So each one of them is a task, or it does some kind of function, and you just basically chain them to each other to achieve what you want. So just following this path, we're pulling from Twitter, getting attributes we want, cleaning up, doing a little bit of cleanup. So we're dropping empty messages. We're replacing, doing some text replacement. So we're formatting the strings. And then merge content here, we're basically, instead of just writing to HDFS each individual tweet, we're collecting, let's say, 1,000 tweets and writing them in bulk. Here. And here we're just putting into HDFS. And what I like about this tool is, like I said, it's very easy. So there you go. I just created here. You've got different processors. So I'm going to create, let's say, another function. So let's say we want to encrypt something. There we go. So we've got an encrypt processor. We take that, we add it, and all we have to do is say drag from here, add this. Must have at least one relation. Okay, I'll do that. Let's pull it from here. Let's say merged. So right now I've actually added another processor to my flow, and you can actually add this processor as the flow is occurring. So it's not like you need to bring down the node or stop the flow to add more things.
Are there decisions that can be made, like based upon maintaining state? When you're working with, say, a traveling average, if anything exceeds a certain average, then you would send it to a particular next step process.
Yeah. So
that's like Storm, right?
So you need some kind of gate time. So it will allow you to do simple processing, simple kind of processing, but nothing too complex.
It's mainly continuous flow.
Yeah, exactly. So you're able to sort of drop messages. You may be able to sort of route based on very simple kind of analytics, but nothing complex.
And it's cold picked or
you wouldn't need to, because this is all happening before it actually hits HDFS. So this is just basically your data data ingestion kind of tool, or data flow kind of tool.
So where the tool lives? Is it on the management node?
So it's going to live on a separate node.
Okay.
So you have a separate cloud, separate box, and you're going to install
This is outside of the ecosystem.
Yeah, exactly. This is outside of the ecosystem, and it can help you sort of, like I said, tie up your different clusters or different systems, data sources and data destinations. It doesn't have to be tied to Hadoop in any way. Hadoop just happens to be one of the endpoints. Yeah, it could be destination or a source, but you can have anything else.
And the first processor that gets the data from Twitter is through the APIs. You specify the APIs.
Yeah. So if you look over here, so like I said, we've got about 130 processors. This is one of the pre-built ones. You can get from database and all that. So here, if you take a look, Properties, I've got everything configured. So I've got my consumer key, I've got my access token, which has to do with my account. So yeah, you literally do not need to code. The whole idea behind this is you can set up data flows, you don't need to write a line of code. It actually won't allow you. There's no
place.
Exactly. There's no place to do that.
Would you need to create multiple processes if you needed to scale to, if you wanted to have 5 connections to Twitter feed, you would need to create 5 instances of each process?
So that would be the case. I mean,
Okay.
Exactly. If you
Yeah,
want to improve
that's
performance, then you would have to create multiple processors or have multiple nodes. Is this a queue for something? Okay, no?
701.
Sorry?
It's 701, so.
Oh, okay, so.
I'm not sure what's gonna happen if we go to 702.
Oh, okay.
Try it.
The area inside
Rounding error.
So how much longer do I have?
As long as you can keep the audience?
Are you guys okay? Okay, yeah.
So it's 7 o'clock, so if anyone has to leave,
Awesome. So there's actually a lot to this tool. I mean, I can spend the next hour just talking about this and showing you different features. This is one I really like, and what I like about it is it's very visual, so it's very nice to demonstrate. I'll keep it very brief. I'll spend probably 3 more minutes on this, and if you have any more questions about it, feel free to ask me later on. But what it does is, so right now, okay, so all of this is stopped. So let me go ahead and start it. Yeah, you've got the stop sign here. So let me go ahead and have it start grabbing things. The whole, and yeah, the process is, it's going to do all the changes, whatever, grab data, and then finally write it to HDFS over here. So this is the first part of the demo. Yes?
Does the Twitter API let you arbitrarily just mine the data off it, or there's some metrics on
yeah.
the types of data
Yeah,
you're pulling in?
thanks for asking. Over here, so terms I'm filtering against, I've got Trump, Carson, Clinton, and maybe I should remove some of those because they're no longer in the running, but yeah. It's just, yeah.
Okay.
But that's where the Lambda architecture would feed back in, that you've got starvation on some of those terms, so you'd actually tune them.
So you can come back and say, okay, fine, exactly, and this will allow you to do that loop, so you can actually have a processor that goes back and says, okay, fine, now change these terms.
Cool.
So now it's grabbing stuff.
Syndrome.
And let me just show something here real quick. So I'm going to stop this process, this particular process, and let me refresh. Oh, I'm not even connected. So it's not picking things up. Do that real quick. Hotspot.
You want to go to NS.
There we go.
Android. Oh.
So anyway, while this happens, while it actually starts to collect data, let me show you something real quick. And a lot of data scientists actually like this for this particular thing that I'm going to show you. So one of the things you can do, you can click on any processor and you can sort of take a look at the statistics. Stats, wrong thing. Okay. You can take a look at the stats. Yeah, I don't have 5 minutes. Anyway, you can take a look at, once we have more data flow, we'll show you. So you can take a look at things like, how many messages actually went through this process within the last 5 minutes, or how many bytes, things like that.
And you can filter based on content. You can filter based on whether the text was or where a person's been.
Yeah, so I'm getting to that right now.
Okay.
So let's take a look. Why is it? Oh, I didn't close it. Okay, so so here we go. So here we've got this whole notion of data provenance or data audit, for instance. And what this allows you to do is we're looking at all the messages that have actually passed through the system at each individual process. Okay, so if we look over here, for instance, these are all the messages that have happened against the pull key attribute process. Okay. Now you can go, let's say, actually no, grab garden hose. Let's see one that's further down the put in solar. Skip that. One that's a little bit further down the flow. Saying like, what was it called? Put HDFS. Put H. You know what? Okay, fine. Let's just take this. So you can click on a message. You've got the timestamp over here. Now the good thing is you can look at the message, look at the attributes, the things that were actually collected from that particular message. So you've got the handle, hashtag, and that's what the message looks like at that particular instant. Okay. You can also take a look at the original okay, this one doesn't have it. So you can take a look at the original content of the message. Sorry.
Does it maintain a graph of the flow within the message?
This, and then we can do that. Sorry?
Does it maintain a graph of its path through the system?
Yeah, and that's exactly what I'm going to show you next. So you can take a look at each. Okay, evaluate JSON. Let me grab this real quick before it disappears. Okay, so you've got, let's say here, content. You can actually see the original content. So this was, let me put it in formatted. This is the actual Twitter message we got.
Served to you by the Twitter API. This is what you got from
Yeah,
Twitter.
this is the actual message that we got, and over here are the attributes we pulled from that particular message. So for that particular processor, this is all we grabbed from that. Now, if we move further along down, for this exact same message, we can see what it looked like under another processor. But for here, let's say, and this is to answer your question, so now you can actually see the route that particular message took.
Cool.
Okay. So for us, attributes were modified, it was routed to a processor. Anyway, so this is all that happened all the way up until it actually reached the put into solar.
Because the interactive nature of this, you can then look at the original payload, decide you want to extract or reduce more content, and then it just continuously makes
It'll just continue to do that, and even better, you can go back and replay your messages. So let's say you've got some algorithm on, you're doing Storm. All this is being fed, the results, messages are being fed into Storm. Now you've built your model, you want to retest your model. You've made some changes to your model, you want to retest them. You don't have to wait for new data. What you can do, or you want to retest the model against the exact same data to see how much more accurate it is. You can go back and say, okay, fine, you know what, play all the messages since I don't know, since yesterday. Replay them. Okay. So it gives you that flexibility. All the data is actually persisted within HDF or within NiFi. And how much data is persisted is totally up to you. So you can have 0 data, or you can have, it really all depends on how much hard drive space you've got.
And will it play it maintaining the spacing between the events, or will it just burst them?
No, it'll just burst them.
Okay.
So let's take, what I did want to show over here is the notion that it would actually, save data, persist the data. So if we brought this processor down, for instance, what you would see is the data sort of buffering at this point. And once we bring this back up again, it'll just process everything. Okay.
And the buffered file system of this?
On disk. So basically, what happens is once the data is read, it's written to the file system, okay, to the local file system, not HDFS, to the nodes file system, and then what happens is we're not passing the data around between these different processors. We're actually doing pass by reference kind of thing. So we're actually passing the pointer around.
Is order guaranteed?
Sorry?
Is order of operation guaranteed, or is the order of the data guaranteed?
I mean, in terms of the sequence,
Right. So if you see Twitter ID 1, 2, and 3.
are they going to be processed in that sequence?
Yeah.
They should be. I don't know. Especially if you start buffering over here, I don't know what order they're going to move in. But I can find out. Leave me your contact. I'll get you an answer to that.
Could it be possible to get data from different data sources and match on IDs?
I was just thinking that Twitter.
Get data from different data sources and merge them based on IP.
Two people make tweets around the
So
same
you
time.
can, so
When I
first,
get data from
answer,
Yeah, that's from.
so you can do that. You can get data from different data sources and you can put that, merge that data together. Whether you can merge based on ID,
It wouldn't, unless you had steps that did different stuff.
I don't know. I think that would sort of constitute more of a complex event processing kind of scenario. So you can get data from, let's say, 3 databases or file systems and format each one and sort of write everything to one file at the end and then sort of, yeah, exactly. Yeah. So this is the first half. So let me jump into the second half of things. So this is Ambari, and so there's 2 points to Ambari. So you've got your dashboard things. This is what I was talking about earlier, but there's also this notion, there's something we call views, and this basically allows you to interact with your cluster in the sense of if you want to do any queries, you want to run any jobs, you do that through those views. So things you've got like, you have a snapshot of the files you've got in your HDFS, so you can upload files, you can download files from HDFS. You can write pig jobs or pig scripts.
So this is the only access you need to give out to your cluster then? Can you restrict views off the tools for a particular account?
Yeah. So this you can restrict who sees what.
So you don't
So
need
you
to
can have
give
somebody
shell
that only
accounts.
looks at IP.
You wouldn't need to give shell accounts into
No.
the cluster.
No, you don't necessarily need to.
Right.
So if this would suit your purposes, then fine.
the only thing that will be missing from here is Uzi.
Yeah, and that's coming in June.
You.
Yeah. So that would be, so it's, what else? There's a few things coming with the next Views version. So Uzi is one of the ones that people ask about.
Do you know which version that you have?
So it's going to be HTTP 2.6, which is, May, June timeframe, so it's a month or 2. Yeah. Let's jump into Hive. Oh, actually, before I jump into Hive, let's take a look at HDFS, where it is we landed. So the data that was written by HDF was
Would have been.
sometime today. Okay, I'm running everything on one VM. Oh, there we go. Okay, so it's going to be a little bit slow. Oh, I shouldn't have done that. Okay, anyway, you saw the files. This is the folder where all the files
It was there.
Okay. So everything's getting dumped into this folder. You've got all the files over there. So let's jump into the Hive view. Okay. So within Hive, this will allow you to sort of create your tables, do your queries, and so on and so forth. So we have so let's look at it this way. You've got the unstructured data, which is your tweets. Those are saved within the folder. And now we want to combine, let's say, with your structured data. And what do we have by way of structured data over here? So I've got a data dictionary. So let's take a look at the contents of that. This is my SQL query that gets generated. Select everything from dictionary. And this basically, it has different words, tells you if it's an adjective, adverb, so on and so forth. And then tells you if it's negative or positive. So very, very, very simple kind of dictionary, nothing too fancy. My second structured data table would be time zone map. And let's say select everything, actually let me just click here, it's easier. Select everything from time zone map. There we go. Okay, so it's got basically the different time zone names and which countries they correspond to. Okay, so Atlantic time Canada basically means in Canada and so on and so forth, and this is going to help us sort of determine where the tweets are coming from. So now I've got a whole bunch of saved queries that I did over there. So my first one was a query to clean tweets. Actually, this would be the first one, and this basically what this query does, your basic SQL query, what it's doing is it's taking the time zone that grabs from the tweet, the message itself, and sort of instead of having that time zone name, it's replacing that name with the actual country. Okay. Okay so far? Okay. Yeah, so it's really not doing much, and doing a little bit of cleanup here and there. The other tweets are one, determining the sentiment of that particular tweet, whether it's positive or negative, weighting that sentiment, how positive or how negative, and then, just computing the general sentiment.
How do you know it's also predicted?
Sorry?
How do you know it's also predicted?
Because we have that data dictionary that's exactly, that's showing, and like I said, this is very, definitely not NLP, what do you call it, level kind of stuff, like, to get the message across. So this is the hype side of things, okay? And you can go in, it's very interactive, you can do your, let's say, let me just go back to the worksheet here, select everything from, hold on. These are this is the final, this table is actually the final results. So let's say select everything from limit 50. Yeah, okay, so here you're going to see the final results. So you've got the tweet ID, the actual message, the country it came from, and the weight for that particular tweet. So in our case, I think, what did I do? I think I did 0 was neutral, 0 was negative, 1 was neutral, and 2 was positive. Okay. And then you have the country that each tweet came from. So this is the hype side of things. So moving on to Zeppelin. So Zeppelin is part of Spark. Let's say, or it interfaces with your Spark engine, your Spark SQL. So it's essentially it's a notebook. It's very similar to Jupyter, Pandas. Exactly. So where do I have this?
Where did you install it? Is it installed in the
It's
management?
it's part of the stack.
Okay.
Yeah. So through one bar you can actually install Zeppelin.
Which version of this?
So the version, I think it's available in tech preview with 2.3.2, and with 2.3.4 it's just there. Yeah. So anyway, so what Zeppelin does is it gives you that ability to sort of go in, write your queries, much so like you're doing with Hive. So here I wrote a query that's basically counts the different tweets that are coming from different countries, and here it's basically the top 400 countries, and these are all the tweets that are there. Some things you can do is, okay, once you write the query, you can view the results in tabular format. You can view them as a graph, pie chart, whatever, so it makes that visualization a lot easier. So what Zeppelin would be used for is for your data scientists to do that exploratory data analysis and sort of model building before actually deploying it. So anyway, so jumping to the results. So this is the final query I had built. And basically what this does is it determines the sentiment based on country. Okay? So if we take a look here, we've got Canada, we've got most of the tweets are actually positive. And I'd say the sentiment is generally positive about the US election. So you've got 540 positive tweets, 233 neutral, and then you've got 151 that are negative. The US, I'd say the ratios are pretty much the same. Mexico, they're generally, you know what, hold on. Yeah, I don't know why they'd be positive about this, but so what I found interesting, so looking at the results, I mean, hopefully I can show that. Let me move that.
Two is negative?
What's that?
Maybe
Exactly, and that's what I need to go back and sort of check what weight I put there. But
I'm actually going to stop you because we're quite a bit over.
Oh, okay.
So first of all, I just want to say thank you very much for being
It sounds like we could have some other sessions with you, one dedicated possibly time. So it's really great. Thanks for making
the trip from Toronto. And thank you everybody for by the night. We'll be meeting in May as well, so the first Tuesday in May, and we've got HP Vertica coming in to go over their architecture, as well as to bring in two speakers to talk about actual use cases that are out in their companies. So looking forward to seeing that. And again, thank you very much.
Thanks for having us.
Learning like seeing what people change, like filter.
No, it's more a basic filter, standardization. So it'll come well.
The kitchen you can see right there. There's like sort of
Last time we did like, PG14, our ratings, 7.4, job count.